GMA Inosanto, and my topic is first come first serve algorithm. What is first come first serve algorithm? It is a non-preemptive scheduling algorithm. Jobs are executed on first come first serve basis. Advantages are easy to understand and yet easy to implement. Disadvantage: poor in performance as average waiting time is high, known as convoy effect. Let's time relate the first come first serve basis algorithm by this example. The process, arrival time, and burst time is given. In order to get the start time, we need to create a Gantt chart. Here is the Gantt chart. In order to create a Gantt chart, you put the process 1, process 2, and process 3. In process 1, the arrival time is 0. And it ends, or burst time, is 12. So, for the process 2, the start time will be 12. And its burst time will be added by the 12 plus 6 is equals to 18. So the process 2's burst time is 18. The process 3 start time is 18 and its end time is 27 from 18 plus 9. In order to get the start time, we need to look at the Gantt chart. The start time of process 1 is 0. The start time of the process 2 is 12. The start time of the process 3 is 18. Next is the waiting time. In order to get the waiting time, we need to subtract start time and arrival time. So start time is 0, arrival time is 0. So the waiting time for process 1 is 0. For process 2 is 12 minus 1. It's 11. For process 3, start time is 18 and the arrival time is 4. So the answer will be 14. For the finish time, we're just gonna look at the Gantt chart where it's finished. The finish time for process 1 is 12. The finish time for process 2 is 18. The finish time for process 3 is 27. Last is the turnaround time. In order to get the turnaround time, we need to subtract finish time to arrival time. Finish time, 12 minus 0 is 12. 18 minus 1 is 17. 27 minus 4 is 23. Now we completed the table. All we need to do is get the average waiting time. In order to get the average waiting time, we need to add all the time in the average waiting time, in the waiting time, which is 0 plus 11 plus 14, and divide it by the number of process, which is 3. The answer will be 8.33. Same process for the average turnaround time. 12 plus 17 plus 23 divide 3. The answer will be 17.33. That is how the first come first served basis works out.
shortest remaining time first. What is SRTF, shortest remaining time first, is a scheduling method that is preemptive version of shortest job next scheduling. In this scheduling algorithm, the process with the smallest amount of time remaining until completion is selected to execute. Let's start the simulation.
Arrives at 0, it enters the ready queue, and is scheduled for one time slice. We reduce the burst time from 3 to 2, and at this point P2 arrives to system and enters the ready queue. We now compare between P1 and P2 and can see that P1 has the shortest remaining time. It is scheduled for 1 time unit. Its burst time is reduced to 1, and at this point P3 and P4 arrives to system. We now compare and can see that P1 has the shortest remaining time. It's scheduled for 1 time unit, and at this point it is out of the system. We now have 3 active processes in the system, and we can see that P2 has the shortest remaining time. We run it for 1 time unit and reduce its burst time from 5 to 4. And we can at this point see that we have been running for 4 time units. And that means that P5 has entered the system. We now compare all of the 4 processes we have in the queue and can see that P5 has the shortest remaining time. We can now schedule it for 2 time units because now we have reached the bottom of the line. P5 is now out of the system. Next one is P2. It has 4 time units left. P2 is out of the system. And now we have 2 processes left, P3 and P4. And P3 is scheduled. And the last process, P4, is scheduled and is taken out from the system. At this point, we can calculate completion time. We can find the turnaround time by taking the completion time minus arrival time. And we can find the waiting time by taking the turnaround time minus burst time. So it has a response time of 2, and so forth. And finally, we can calculate the average.
Good day everyone. My name is Ron Cyril M. Sakita and I'm going to show you how round robin works. Before I start, what is round robin algorithm? Round robin is a CPU scheduling algorithm where each process is assigned a fixed time slot in a cyclic way. Ibig sabihin, every process, binigyan sila ng time limit to execute at the CPU. So, we have a 4 process at meron silang mga sariling time to burst at the CPU. Bago tayo mag-umpisa sa Gantt chart, we need time quantum, which example 3 seconds. So this is our Gantt chart. So CP1 mag-uumpisa sa line. So nung tapos siya at time of 3 seconds, so ibabawas natin yan sa remaining time niya. So 17 minus 3 is equal to 14. So ang remaining time niya is 14. Next is si P2 naman. So pumasok siya at the time of 3 seconds at matatapos siya at the time of 6 seconds. So ibabawas din natin yung nagamit niyang oras. So 3 minus 3 is equals to 0. So wala na siyang remaining time. So tatanggalin na natin siya. So next is si P3. So pumasok siya at the time of 6 seconds at natapos siya at the time of 9. So, ibabawas din natin sa kanya yung 3 seconds na nagamit niya. 6 minus 3 is equals to 3. So may natira pa siyang 3 seconds. So next is si P4. So pumasok siya ng 9 at the time of 9 at natapos siya at the time of 12. Ibabawas din natin yung nagamit niya. 3 minus 3 is equal to 0. So wala na siya natirang time. Tanggalin na din natin siya. So next is CP1 ulit. Ayun yung tinatawag na round robin. Babalik lang ulit sa umpisa. So CP1 ulit. At natapos siya ng 15. Bawas ulit natin sa kanya. 14 minus 3 is equals to 11. So next is CP3 naman. Pumasok siya ng 15 at the time of 15. Natapos siya nung 18. Bawas din natin. 3 minus 3 is equal to 0. So natapos na rin siya. Tanggalin na rin natin. So CP1 na lang natira. Ibig sabihin, uunin niya na lahat. Ay, gamitin niya na lahat ng oras na natitira niya. So, that's how round robin works.
I am Angelica Herrero Sinyata and I will discuss about multi-level feedback queue scheduling. So, what is multi-level feedback queue scheduling? The multi-level feedback queue scheduling algorithm allows a process to move between queues. The idea is to separate processes according to the characteristics of their CPU bursts. If a process uses too much CPU time, it will be moved to a lower priority queue. This scheme leaves IO-bound and interactive processes in the higher priority queues. In addition, a process that waits too long in a lower priority queue may be moved to a higher priority queue. So let's take a look how multi-level feedback queue scheduling works. So here are having three queues, Q0, Q1, and Q2, whereas Q0 is having the highest priority and Q1 is having the next highest priority and Q2 has a least or the lowest priority. So these are the three queues scheduling. There will be processes belonging to these different queues and there will be some scheduling algorithms that each queue will be following, and the processes will be scheduled using those scheduling algorithms within the queues. Also, there will be a scheduling among the queues based on the priority of the queues. Now let's see what happens in multi-level feedback queue scheduling. In this example, we see that Q0 the queue of the highest priority. So the processes in Q0 will be the first one that will be executed. And after, when all the processes in Q0 have completed their execution, only then processes belonging to Q1 will be able to be in their execution. And similarly, all the processes belonging to Q2 will be able to do their execution only when Q1 and Q0 are empty, because that is how the priority works. So processes belonging to queues of lower priority will be able to execute only when the queues of higher priorities are empty. So that same thing will be followed even in these multi-level feedback queues. Let's say that within these queues there are certain algorithms that are followed for scheduling. So let's say that in a Q0 there is something like a round robin scheduling. It may not be exactly a round robin scheduling, but just like a round robin scheduling where the quantum of time is 8 milliseconds. That means process will be allowed to execute for 8 milliseconds. That is the time quantum, and then in Q1 the processors will be allowed to execute for the quantum of 16 milliseconds. And in Q2, the processors are scheduling using a first come, first served scheduling algorithm. So in this multi-level feedback queue scheduling, what will happen is the first of all the processes in this process Q0 will be allowed to execute. So the first process that is at the head of the queue will get the CPU for execution, and it will be allowed to execute for a time quantum of 8 milliseconds. So if that process completes its execution within 8 seconds, then well, it's good. But if the process did not complete its execution, then what will happen is that the process will be moved from Q0 to the tail of Q1. So if the process executing in Q0 does not complete its execution within the time quantum of 8 milliseconds, then the process will be moved from Q0 to the tail of Q1. Minded to the tail of Q1, and then again the processes in Q1 will be allowed to execute, and then they will be allowed to execute only when Q0 is empty. Let's assume that Q0 is now empty, and then the process in Q1 can now begin their execution. So the first process that is at the head of Q1 will begin its execution, and there is a time quantum of 16 milliseconds here. So if a process can complete its execution within 16 milliseconds time, then it is finished. But if it is not finished within the time quantum of 16 milliseconds, then the process will again be moved from the Q1 again to the tail of Q2. That the process will be moved from Q1 to the tail of Q2. So the same thing that happened is happening here as well. So the processes move to the tail of Q2 if it did not complete its execution within the time quantum of 16 milliseconds. And in Q2, the processes will be scheduled using the first come, first served scheduling. The processes in Q2 will be able to execute only when Q1 and Q0 are empty, because this is the least priority queue. Here we see there are scheduling happening among processes within the queues. There is also scheduling among the queues themselves. Also, we see that there are processes moving from one queue to another. So this is like an extension to the multi-level queue scheduling.